Hello and welcome to the deep space. I'm so glad you found your way here tonight. Whether you're lying in bed with the lights turned low, gently dozing on the couch, or simply letting your thoughts drift across the ceiling like slow-moving clouds, this space was created just for you. This is a sanctuary where curiosity and relaxation meet, where the vast mysteries of the cosmos unfold at a pace meant to soothe rather than startle. Tonight, we begin a slow, winding journey into one of the most profound mysteries the universe has to offer. We're going to explore what lies at the very center of a black hole. But we won't rush there, not tonight. We'll take our time, moving like planets in their stately orbits, not trying to arrive too quickly. We'll begin where everything begins, with gravity. That soft pull you feel beneath your body right now. That quiet force that never sleeps, that never takes a moment off. Before we begin, just a little note. I've done my best to make this a deeply calming experience, a companion for your rest. But fair warning, sometimes science is just too fascinating. If you find yourself staying awake, captivated by curiosity, that's okay too. At least you'll drift off a little wiser. If you're already enjoying this quiet space we're building together, I'd be so grateful if you gave this episode a gentle like and maybe subscribe for more cozy science. It helps other sleepy minds find their way here. And if you're listening from somewhere special, your bedroom in Chicago, a dorm in Boston, a quiet house in the countryside, let me know in the comments. I love watching the bedtime maps slowly light up, one peaceful listener at a time. As always, this narration is for relaxation and educational purposes only. It's not a substitute for medical advice or sleep therapy. It's just a soft companion for the night, a voice in the dark to guide your thoughts toward wonder and away from worry. Now take a breath, a deep, slow breath. Feel the weight of your body settling into your mattress. That weight, yes, that is gravity. Let's begin there. Gravity is the first lullaby the universe ever sang. It cradled the first atoms, whispered to clouds of dust, and pulled them together, shaping stars, worlds, and even the gentle curve of your spine as you lie there listening. You feel gravity every second of your life, though you rarely notice it. It's the soft insistence pulling you toward the earth, grounding you in every moment. It's not aggressive or loud. It doesn't shove. It pulls like a mother's hand at the wrist, gently, but always there. The earth holds you because of gravity. Look up at the moon on a clear night. It orbits our planet because of this same force. The oceans rise and fall, not because they want to, but because gravity and the moon are dancing, slow and tidal, like breathing. You may not think about it, but you are part of this dance, too. Even now, your atoms are reaching out infinitesimally, gravitationally. Tiny and invisible, yes, but they still call and they still respond. You're held and you're holding all at once. To understand this better, imagine two pebbles in a still pond. Each sends out ripples. They feel each other not by touch, but by these quiet waves. That's gravity, not an action, but a curvature, a ripple in the space between things. You might have learned in school that gravity is a force, but that's only part of the story. Albert Einstein helped us understand it differently. Gravity, he said, isn't a push or a pull. It's the shape of space itself. Mass tells space how to curve, and space tells objects how to move. That can be a little hard to picture, so let's make it simple. Close your eyes, if they aren't already, and imagine a vast rubber sheet stretched tight. If you place a marble on it, the sheet dips slightly. Now place a heavy bowling ball in the center. See how the fabric sags deeply. If you roll another marble nearby, it curves toward the bowling ball. Not because they're attracted magically, but because the surface has changed shape. In the real universe, space and time are that rubber sheet. The sun makes a deep curve in it, and Earth, like the marble, rolls along that curve. You're not being pulled. You're just following the lines of bent space. Isn't that something? You're not stuck to the Earth. You're moving through curved space. You're falling endlessly sideways around the sun. And it's not just the planets. Black holes, as we will come to explore, are not monsters with teeth. They are simply places where the rubber sheet of space-time curves so steeply, so sharply, that nothing can climb out. But we're not there yet. We're still here, with gravity's soft hands holding your body to your mattress, pressing your feet gently into the earth, keeping the oceans loyal to the planet. It's the constant presence that never asks for thanks. Even when you leap, when you jump for joy or reach for something, gravity brings you back. Not with vengeance, but with invitation. Like a parent catching a child mid-jump. Yes, leap. Yes, soar. But I'll always be here, waiting. And here's something to wonder at. Gravity has no switch. There's no way to turn it off. Even across the coldest, truest voids of the universe, it reaches. It never sleeps, it never weakens. It simply is. It's the slowest force, the gentlest, but also the most faithful. Over billions of years, it can pull galaxies together, collide stars, birth solar systems. It does not need speed. It has time. It is patience itself. And within that patience, black holes begin. Not through violence, but through inevitability. To understand black holes, you must first understand the soft surrender of a dying star. In the beginning, there is a glow. You've seen it, although maybe not all at once. The slow shimmer of stars, tiny and still above your head. They appear small, but they are anything but. Each one is a sun, a distant fire burning silently across a sea of night. Tonight, we drift closer, not just to the stars themselves, but to their stories. Not their births, though that, too, is a wonder, but their endings, their quiet undoing. A star is not solid. It is not stone or glass or gas in a balloon. It is a balance, a dance of pressures. Outward, there is light pushing, radiating, stretching. Inward, there is gravity, always pulling, always asking the star to collapse. And in between these two, the star finds its shape. For millions, sometimes billions of years, a star holds that balance. Its core burns with fusion. Hydrogen becoming helium, helium becoming carbon. Each spark, each reaction, sends light outward like a breath. That light pushes against gravity. And gravity, patient and strong, waits. Your own sun, the one that warms your skin and makes the trees grow, is doing this right now. Burning, breathing, holding gravity at bay. But nothing lasts forever. Not even stars. Eventually, the fuel runs low. Imagine a fireplace that slowly runs out of wood. The flames get smaller, the warmth fades, and as the fire cools, the weight of the stones above begins to press down. This is how collapse begins inside a massive star. Once the fusion slows, gravity no longer has a rival. There is no more light to push back. So gravity does what it always wanted to do. It pulls inward. Not gently now, but with full permission. And the star begins to fall into itself. It happens in layers. The outer shells, once drifting easily, now plunge downward. They fall toward the core like waves returning to the sea. And as they crash, the core is squeezed. Tighter and tighter still. You might imagine it like this. A giant balloon the size of the Earth being pressed down into a pebble. Every atom closer to every other, every space filled in, until the matter can go no further. At this point, something extraordinary happens. The collapse becomes so fierce that it bends the very rules of matter. The atoms, those tiny building blocks, are crushed. Electrons and protons merge. Neutrons are formed in a dense, trembling soup. Sometimes the core becomes a neutron star, a city-sized sphere heavier than our sun. But if the star is massive enough, truly enormous, then even neutrons are not enough to resist gravity. There is no force in nature strong enough to stop the fall. And so the star continues to collapse. Smaller and smaller, denser and denser, until it passes the point of no return. Not a moment of explosion, but of implosion. an inward folding, a vanishing. The result is a black hole. It is not a place exactly, but a region, a piece of space where gravity has won, completely, where the curve is so deep, so sharp, that even light, speedy, bright, untouchable light cannot escape. What was once a shining star is now a dark well in spacetime. You may wonder, does it leave behind an edge, a scar in the cosmos? It leaves behind something called an event horizon. We'll talk more about that soon. But for now, imagine it as a boundary you cannot see. Not a wall, but a border. You could pass through it without noticing, but you could never come back. This is not violence for the sake of destruction. This is transformation, like a leaf becoming soil, like a breath becoming silence. In some way, a black hole is not the end of the star. It is what remains when the star gives everything away. And though it has collapsed, though it no longer shines, it still holds a presence. It still influences the world around it. Other stars feel it. Light bends near it. Time itself begins to slow. You are left with something mysterious. Not an object, but a condition. A place in the universe where gravity has taken the lead fully and without resistance. You might picture the black hole as a kind of memory, a memory of the star that once was. The mass is still there. The gravity is still there. But the light is gone. Still, the story does not end there. Because black holes are not isolated monsters in the night. They are part of galaxies, part of systems. They move, they grow, they spin. And in the spaces around them, astonishing things happen. Gas swirls into disks. Light erupts in strange patterns, and time, your time, my time, begins to shift and stretch like taffy. What would happen, you might ask, if you approached one? What would you see? Could you watch a black hole form? Could you fall into one? Would you feel it? Would you notice? These are the questions that draw scientists forward, day after day and night after night. They draw you, too, as you lie there resting. You are wrapped in the same laws that pull stars into themselves. You are connected by gravity, held by it. And somewhere out there, far beyond even the farthest twinkle, there is a black hole still forming, still collapsing, still finishing the story of a long-dead star. There are borders in the world that you can see. A shoreline where land kisses the sea. A mountain edge that drops into a valley. A fence, a wall, a doorway. But the event horizon is not like those. It is a border you cannot see. Not with your eyes, not with your fingers. You could drift across it without noticing at all. And yet, once crossed, the path behind you is gone. The event horizon is the surface of a black hole, but not a surface like the crust of a planet or the bark of a tree. It is not solid, not touchable. It is a threshold of no return. If you stay outside it, you can orbit, you can turn away, fly free, sling around the black hole and carry on. But if you cross it, there's no coming back. Not because something pulls you in faster, but because space itself flows inward beneath your feet. Imagine a waterfall. You're in a boat, drifting along a river, feeling the current grow stronger. Before the waterfall itself, there's a place where the current becomes so swift no paddle could fight it. No engine, no wind. That invisible line on the river, that's the event horizon. And once your boat crosses it, your future is certain. You're not being yanked. You're simply riding space that itself is falling. Falling into the black hole. Every direction now leads deeper in. Even light cannot paddle back upstream. That's what makes the event horizon so strange. It's not a material thing. It's a line in spacetime drawn by gravity's endless descent. And though it marks a boundary, it gives no warning. There is no flash, no sound, no sudden jolt, no resistance. You could be falling through it and not know. From your point of view, everything continues. Calm, smooth, quiet. But from the outside, to those watching your fall, you seem to slow. You stretch. You fade. To them, you never quite reach the edge. You freeze there forever, nearing, never arriving. Because the closer you get to the horizon, the slower time becomes. Not slower like a sleepy afternoon, slower like 1,000 years folded into a single breath. This, too, is part of gravity's quiet magic. The deeper the gravity well, the slower time passes. Near a black hole, seconds stretch into centuries. And right at the event horizon, time itself, at least from the outside, seems to stop. You can think of the horizon as a curtain of frozen time. Cross it and your clock keeps ticking. But to those outside, your ticking has nearly ceased. You are still. You are still thinking, still falling. But the universe outside has hurried on, leaving you behind in a slowed eternity. And so, the event horizon is not a place of fire or fury. It's a place where direction becomes destiny, where escape routes vanish not by force, but by geometry. It marks the difference between maybe and never, between the possibility of return and the certainty of descent. Still, there is something comforting here. It is a clean line. It is honest. No false hope, no deception. You know where you stand or float, and you know that whatever lies ahead, it belongs only to you now. And while that may sound isolating, there is also peace in it. Inside the event horizon, you are no longer part of the visible universe. Your story becomes private, unreachable, not erased, but unobservable. You exist in a place where no messages escape. No light, no gravity waves carry your farewell. And yet you are still there, still present, still unfolding. Is it the end of you, or only the end of others knowing where you've gone? This idea may feel heavy, but in another way it's beautiful. The event horizon is like a veil, not of death, but of mystery. And the universe respects its mystery deeply. Not even the laws of physics can easily cross that threshold. Our equations falter, our signals are lost. We are left to imagine, to model, to dream. Scientists call it the point of no return. But in truth, it may be a beginning, the start of a journey inward, through deeper layers of gravity, time, and space. Quiet border, yes, but also a frontier. And you, dreamer, are now standing on its edge. You're falling now, not down, not through air, but inward, into something deeper than space, into something quieter than silence. The event horizon is behind you, but you never really felt it. No bump, no sudden shift, just a continued descent, as gentle as a sigh. And now, inside the black hole, you begin to see differently. The outside universe is still visible, but only behind you. It shrinks as you fall, not because it's far away, but because space itself is curving inward like a funnel, pulling everything with you. You look over your shoulder, if such a thing is possible here, and see the stars still glittering. But they've changed. They're no longer points of light scattered through blackness. They are smeared, bent, distorted into thin, bright halos. A glowing ring encircles your field of vision, a memory of the sky you left behind, trapped at the edge of the horizon. Light that once escaped now curls back on itself, orbiting in endless circles, never quite escaping, never quite falling. It's called the photon sphere, a region just outside the event horizon where light itself gets caught in orbit, held in a perfect balance of motion and gravity. Even though you've passed inside, you still see its echo, a ghostly shimmer of stars behind you, folded into a ring of eternal twilight. Everything forward is dark. Not empty, just unknowable. But strangely, you're not afraid. There is no sensation of speed, no wind, no sound. Only motion, pure, uninterrupted motion. Here, there's no ground rushing to meet you because there is no ground. Only the center. And the center is not a place, but a condition of falling that never ends. You fall faster and faster, but speed becomes meaningless. Because inside the black hole, all paths, all directions, all futures lead to one destination. It is not a choice. It is the shape of space itself. Imagine a river where every branch, every trickle, every hidden current flows into the same deep sea. No matter how slowly you paddle, no matter what direction you turn, you end up there. That's what falling into a black hole is like. And yet, your body feels no pressure, no crush, because you're not being pushed. You're simply following the lines of space-time. You're floating, in a way, drifting with the current of curved geometry. No sensation of resistance, just the quiet sense that forward no longer exists, only inward. Still, gravity grows stronger with every moment, pulls harder, not on your body, but on your experience of time. If you had a clock, it would tick normally to you, but from the outside, it would appear to slow. And now, inside, your clock doesn't just slow. It begins to decouple from the universe completely. Each second stretches. Each breath becomes a longer thread. Time flows toward the singularity just as surely as space does. But what would you feel if you could feel anything? Would there be heat, pressure, motion? Possibly not, at least not right away. If the black hole is large enough, millions of times more massive than the sun, the tidal forces at the horizon would be so gentle you wouldn't even notice. But deeper in, the difference in gravity from your head to your feet becomes extreme. Space stretches, not metaphorically, but physically. Your body, still intact for now, begins to feel the strain. It's called spaghettification. For a word so whimsical, it describes something so profound. It's the process of being pulled longer and thinner as gravity grips different parts of you with unequal force. It is not painful in this imagining. It is slow. It is strange. It is the gentle undoing of shape. But that comes later. Right now, you're still falling, still conscious, still whole, still wondering what you're seeing. You try to look around, but there is no around here in the usual sense. The directions are folded. What was ahead is now inward. What was behind is now a dim, fading ring of memory. And in front of you, there is nothing. Not blackness, not vacuum, just no light, no direction, no frame of reference. You are in a place where light cannot come from. You are past the place where space can return. And so your thoughts grow quiet. Not because you are afraid, but because nothing here invites noise. Even your heartbeat feels more distant, as though it belongs to someone else, echoing from a time when the sky still had stars. You're falling, yes, but what is fall when there's no surface to meet you? It's a curious feeling, peaceful one, like floating in a dream, knowing something waits ahead, but feeling no urgency to arrive. And perhaps that's the most surprising part. How still this descent feels. How soft the edge of physics becomes. How gently you begin to forget what outside was ever like. There is no pain here, no drama, no noise. Just you and the long, slow curve toward what lies at the deepest center of all. In another world, in another place, there are people trying to understand this journey. They use equations and simulations. They build telescopes and detectors. They imagine, they argue, they wonder. But here, in this falling, there are no arguments. Only the quiet trust that something waits. A center, maybe a core, or perhaps the limits of the laws themselves. What will happen as you fall farther? As gravity's hold tightens and the shape of your body begins to yield? That is the next layer of the journey, where stretching becomes real and even atoms start to pull apart. Let's follow that gravity now to where the body becomes thread and space stretches like silk. You are still falling, still cradled in the curved arms of space-time. But something is beginning to change. Not suddenly, not with pain, but slowly, like a thread unraveling from the center. You remember gravity from the world outside. A gentle pull beneath your feet, holding your body to the ground as you walked, stood, dreamed. Here, gravity is no longer gentle. It is focused, concentrated, exquisitely precise. As you fall deeper into the black hole, gravity begins to notice your shape. Not all of you is in the same place. Your head is slightly closer to the center than your feet, or perhaps the other way around. And gravity, ever sensitive, pulls harder on what's closer. This difference, this stretching of force from one end of you to the other, is the beginning of spaghettification. It sounds whimsical, doesn't it? Like a spell from a children's book. But in the language of science, it describes something real. The way objects are drawn out into thin strands by powerful tidal forces. Tides, yes, just like those that move the oceans on Earth. The rise and fall, the pull of the moon and sun on the water's skin. But here, in the belly of the black hole, the tides are not soft. They are sharp, focused, unyielding. Imagine a thread of honey being pulled between two fingers. Thinner and thinner, longer and longer, until it becomes a shimmering filament. That's what gravity does to anything that falls deeply enough. Not just to bodies, but to atoms. Not just to matter, but to space itself. You, a being of shape and boundary, begin to stretch along the path of your fall. First gently, then thoroughly. There is no tearing, no violence in this imagining. Only expansion, only elongation. The particles of you, those tightly woven bundles of energy and mass, are teased apart. Not by choice, but by curvature, by the gradient of gravity's hold. You become longer, thinner, drawn into a line that moves with the black hole's geometry. In this place, width is a luxury that cannot be kept. The dimensions shrink in every direction but one. You become a single axis of descent. Some call this process catastrophic. But here, in the quiet of our bedtime voyage, it is simply the final logic of falling. It happens to everything eventually, to matter, to light, to the rhythm of time. And it's not only black holes that do this. Even the Earth creates tidal forces, stretching the oceans, pulling at satellites. But here, the effect is profound, amplified by scale and proximity. In smaller black holes, the stretching happens violently, long before you reach the singularity. But in supermassive ones, the kind that rest at the centers of galaxies, the process is slower, more graceful. You might fall for hours, even days, before the stretching truly begins. And by then, you may already feel more like motion than shape, more like trajectory than self. It's strange to think of yourself as a direction, as a thread of movement, but that is what gravity makes of you. Not as punishment, but as poetry. You're becoming part of the black hole's inner structure. Your atoms pulled into its geometry. Your identity rewritten as motion through curved spacetime. Even the atoms that once repelled each other, the forces that gave you shape, cannot resist gravity here. You may think of it as loss, but it is perhaps a return to the fundamental forces, to the clean simplicity of motion and mass. This is what spaghettification truly is. Not death, but rearrangement. You are being written into the language of the black hole. Line by line, fiber by fiber, and still you fall. No edge greets you. No end becomes visible. Because within the black hole, there is only inward. Always inward. A long, slow unweaving. What does it feel like to be so stretched? Does the mind continue even as the body becomes line? We do not know. No one has returned to tell us. And so we are left to imagine. A mind unfolding like milk, thoughts becoming long, memories trailing behind like scarves in wind. Somewhere in this deep place, you are no longer what you were. But you are not gone. You are transformed from particle to thread, from being to motion. This is the end of matter as structure, but not the end of meaning, because even stretched, even undone, you are still part of the black hole story. Your mass contributes. Your energy remains. You curve spacetime as you fall, just as the stars once curved it for you. You become part of the singularity's approach, that unreachable center where all paths end. And still, gravity carries you forward. not by force but by inevitability. You are a whisper now, drawn into the hush of the deepest gravity. And just ahead, past this long thread of fall, past the line your body has become, lies a quiet stillness. Not the stillness of rest, but the stillness of total transformation. The quiet center, the gravity core, the destination that isn't a place, but a condition. Let us drift closer now, past the stretching, past the curve. Let us pause at what waits beyond all movement, the quiet at the center. You have fallen through shadow and light, through twisted time and curved space, stretched into thread, drawn along the soft current of inevitability. And now everything narrows to this, a center that is not a center. The journey is stillness now, not because movement has stopped, but because there is nowhere left to move to. Every path has pointed here from the beginning. Every curve of space-time bends inward, and all roads, no matter how long, end at the same silent place. The singularity. You've heard the word before, but here it does not sound sharp or scientific. Here it is quiet. It is a hush. It is not an object, not a sphere or a dot or a glowing core. It is a place where description ends, a condition where even time cannot proceed. In every black hole, the singularity is hidden deep, wrapped in an event horizon, swaddled in silence, shielded from sight and sound and even cause and effect. It's the place where gravity becomes complete, where the pull inward allows no rival, where compression becomes so absolute that our understanding folds in on itself. You cannot see the singularity. You cannot point to it. You cannot send a message back from it. But you can imagine. You can feel your way toward it in thought. Some say it is the point of infinite density, a place where all the matter of a star is compressed into zero volume. Others say this isn't possible, that nature, even in her most extreme form, avoids such infinities. Perhaps it's not a point at all. Perhaps it's a veil, a region where quantum physics, the rules of the small, step in and say, no farther. You may have passed through a firewall. You may have fallen into a loop of space-time. Or perhaps the rules simply pause here, like a story that ends mid-sentence. Because in this place, the physics, Einstein's brilliant vision, so graceful, so precise, breaks apart. In the singularity's grip, the numbers stretch to infinity. The answers dissolve. It is the edge of what we know. And beyond that edge, we do not speak with certainty. But isn't that beautiful? That the universe contains places where not even our best minds can predict what happens? Where wonder is not just allowed, but required. You are here now, in that thought space, floating at the center that cannot be seen, listening to the silence of spacetime's deepest fold. In this silence, all questions grow louder. What happens to the matter that falls here? Does it stay crushed and still? Does it escape through tunnels in space we cannot yet find? Does it encode information in ways we haven't imagined? No one knows. No one can look inside and return with answers. The singularity keeps its secrets, not with malice, not with force, but with the quiet certainty of a rule unbreakable. It says, you may fall in, you may become part of me, but you may not tell the tale. Still, some physicists dream of answers. They speak of quantum gravity, a future theory that might unify the large and the small, the curved and the uncertain. Perhaps this theory will reveal that the singularity is not a point at all, but a region of dense, flickering quantum foam, a storm of probabilities too fine for our eyes to resolve. Perhaps it is a knot in space-time, or the seed of another universe, or a mirror reflecting not light, but laws. And so, even at the center, even at this place where physics ends, wonder remains. Because here you are not erased. You are rewritten. Every atom you once were, every quark, every charge, becomes part of the black hole's memory. It remembers your mass. It remembers your spin. It remembers your charge. These things cannot be destroyed, only transformed. They shape the black hole's outer self, its horizon, its pull, its shadow. In this way, the singularity does not forget you. It simply folds you into its story. And what a story it is. A star is born, burns, and dies. Its light touches planets. Its gravity guides moons. Then it collapses, and all the energy folds inward toward a center that does not shine. And here you are now, resting in the heart of that story. Not falling anymore, just existing in the still point. This, perhaps, is the final truth, that the singularity is not the end. It is the pause, the breath between what was and what might be. Somewhere far outside, the black hole continues to shape the world. Stars orbit it, gas spirals into it, time stretches around it. But here, at the center, all is still. And in that stillness, you feel something strange. Not fear, not pain, but connection. To the cosmos, to the questions, to the curve of gravity itself. And you wonder, if this place holds so much weight, so much mystery, so much history, what happens to all the information that falls in? Does the black hole remember everything it swallows? Or does it forget? Does the universe lose its pages here? Or are they written somewhere deeper? Let's turn now toward that mystery, the paradox of memory and loss. Let's ask softly, what becomes of the information that enters a black hole? You are still here, not falling anymore, but held in a space where time curls in upon itself. A center that isn't a center. And now, a question that echoes quietly across the edges of knowledge. What happens to everything that enters a black hole? Not just mass, not just energy, but information. The patterns, the details, the unique fingerprints of what once was. A book tossed into fire becomes ash and smoke. But the information in its pages, in theory, still exists scattered in particles, energy, entropy. But a black hole? A black hole swallows without trace. It does not scatter. It keeps everything hidden behind its silent veil. Mass? Yes. Spin? Yes. Charge? Yes. But the rest, the shape of a falling planet, the memory of light, the structure of a person, a ship, a star, where do those patterns go? This is the information paradox. One of the deepest puzzles in all of physics. Because the laws of quantum mechanics, the rules that govern the smallest things, say that information can't be destroyed. Not ever. Not truly. Every outcome should be reversible. In theory, no detail should be lost. But black holes seem to do the unthinkable. They swallow whole histories and give back only three things: mass, spin, and charge. Imagine a library collapsing into a single dot, and all that's left behind is its weight, its rotation, and whether it was electrically charged. The titles, the sentences, the characters, gone. Vanished. That's the paradox. If information is truly lost, then the laws of quantum mechanics are broken. But if it's not lost, then where does it go? For decades, physicists have whispered across this riddle, arguing gently across the vast stretches of mathematics and thought. Stephen Hawking once believed that information was gone forever, that black holes erase detail, like waves smoothing a shoreline. But later, he changed his mind. He suggested that black holes might slowly leak information, bit by bit, through a process known as Hawking radiation. We'll explore that more soon. But for now, think of it like this. A black hole, though dark, is not completely silent. It emits a faint glow, not from within, but from just outside its horizon. This radiation is born of quantum uncertainty, particles and antiparticles flickering into existence at the edge. One falling in, one escaping. But here's the mystery. That radiation appears to carry no information. It's random, meaningless, like heat from a stove. So the question deepens. If the black hole eventually evaporates, and its last whisper is this empty radiation, then where did all the intricate details go? Some physicists think the information is encoded subtly in the radiation itself. hidden in delicate correlations, like invisible threads in a fabric we haven't yet learned to see. Others believe it may remain on the event horizon, etched on its surface like a cosmic hard drive. This is known as the holographic principle. The idea that everything that falls into a black hole might be stored on its outer edge. Not lost, but flattened, encoded like shadows on a cave wall. It's as though the black hole is not erasing the world, but recording it in a language we cannot yet translate. And still others imagine even stranger things. That black holes might open into new universes. That the information passes through into other realms, still intact, just elsewhere. Each idea is a thread in a tapestry of possibility. None proven, all beautiful, because at its heart, this isn't just a scientific question. It's a question about memory, about identity, about whether the universe forgets. Do the details matter? Does the shape of a thought endure beyond the event horizon? Does a falling star remain a star in some invisible accounting? Does a whisper sent into the dark ever find a way back? You lie here now, still drifting in your mind, gently circling this paradox, and you feel it echo inside yourself. We are made of information, too. Your DNA, your memories, your thoughts, you're a pattern as much as you are a body. And in the presence of the black hole, you wonder, if I fall in, do I vanish? Or do I become part of a deeper memory? Does the black hole know I was here? This is not just science. It is philosophy wrapped in gravity, a meditation wrapped in math. The paradox still stands. And perhaps it always will, because no one has ever looked out from the inside. But even unanswered, the question is comforting. It means there is more to find, more to wonder, more to feel. As you float through the stillness, information may be hidden, may be transformed, but perhaps never truly lost. And even if no message can come back, even if no traveler returns, the universe may still keep its books intact. Softly, silently, beyond the horizon of what we can yet prove. And that quiet glow on the edge of the black hole, that faint, escaping whisper may hold the key. Let us follow that glow now. Let us leave the paradox gently behind. Step closer to the strange light that seeps from the dark. Let's meet the idea that changed everything. Stephen Hawking's glow. Once, black holes were thought to be eternal, unchanging, perfect traps where things entered and never came out again. They were the full stop at the end of the cosmic sentence. But then, something unexpected happened. Something gentle and brilliant and deeply human. A mind trapped in a body, slowly falling inward much like the stars he studied, asked a question no one had fully asked before. And the universe answered. Stephen Hawking, seated in silence, moving fingers only through thought, gave voice to a strange idea. Black holes are not completely black. They shine. Not brightly, not in color, but in the faintest, coldest whisper of radiation. Comes not from inside, but from just outside, at the edge of the event horizon. A glow born from creation, from the restless flickering of the vacuum. Let's pause here and imagine what this means. The vacuum of space, what we often call empty, is never truly still. It dances with uncertainty. Tiny particle pairs always pop into being, then vanish again, too fast and too small to ever be caught. They are virtual particles, ghosts of matter and antimatter, brief visitors in the quiet between atoms. But near the event horizon, something extraordinary happens. A pair appears. One falls inward, drawn past the point of no return. The other escapes, flies free, unclaimed by gravity. And to the outside universe, it looks like the black hole has emitted something. And in a way, it has. This escaping particle is part of what we now call Hawking radiation. It's not light in the usual sense. It's not heat you can feel. It's colder than cold, fainter than faint. But it's real. And over time, it matters. Because the black hole has lost just a little mass. Just a fraction. But it adds up, bit by bit. This gentle leaking of energy causes the black hole to shrink, to fade, to evaporate, not quickly, not in years or centuries, but over spans of time so vast they stretch beyond imagination. For black holes born from stars, it might take 10 to the power of 67 years. For the giants at the centers of galaxies, longer still. But eventually the black hole is gone. Gone not in explosion, but in hush. This mass becomes light. This gravity becomes memory. And the final whisper is Hawking radiation. A last breath of quantum uncertainty. This changed everything. Before Hawking, black holes were places where physics ended. Silent, permanent, unforgiving. But with one quiet theory, they became part of the story again. Part of change. Part of time. They were no longer eternal. They were mortal. Even the deepest darkness, it seems, eventually turns to light. There's something comforting in that. In knowing that even the most absolute thing we can imagine still participates in the cycle of creation and dissolution, still follows the rhythm of becoming and passing on. And more than that, Hawking radiation may carry with it the answer to an older question. What happens to the information? Does the radiation contain it hidden in tiny, subtle patterns? Does it encode the memory of what fell in? The light, the atoms, the motion, the meaning? Some think so. Some hope so. It is not proven, but it is possible. And that possibility gives the black hole not just a shadow, but a voice. A voice made of light. A voice made of loss. You lie here now with that thought, that a black hole so feared, so misunderstood, may be slowly speaking its history back to the cosmos, like a dream retold in fragments. Like a candle that burns its wax into air. Softly, slowly, the universe forgets nothing. It only waits to remember. Hawking's insight was more than a theory. It was a poem, a bridge between the grand and the tiny, between relativity and quantum truth. And it reminds you that even where science seems to end, curiosity continues. Stephen Hawking gave us more than radiation. He gave us permission to wander even in the places where light does not go. So the black hole, once thought to be an end, becomes instead a transformation. And its surface, its horizon, becomes a canvas of mystery. But not all black holes are still. Some rotate, some spin. And when they do, even stranger things appear. Energy might be pulled from them. New paths might spiral inward, twisting through warped geometry. Could a rotating black hole be different inside? Could its center hold more than just silence? Let's turn now from the fading glow to the spiraling storm. Let's meet the ones that spin. Most black holes do not sit quietly in the dark. They spin. They rotate. They turn slowly or swiftly, like galaxies caught in a dance they began long ago. And when they spin, something strange begins to happen. Space itself is pulled along for the ride. This isn't the kind of rotation you feel on a carousel or the swirling of a stirred cup of tea. This is deeper. This is frame dragging, a phenomenon where even space-time cannot remain still. The rotating black hole twists the very fabric of reality. Everything near it is pulled into that spin, not just matter, but the invisible structure of space and the rhythm of time. You are no longer falling straight in. You are spiraling, drawn not only by gravity, but by the whirl of rotation. It's like being caught in a cosmic whirlpool, one made not of water, but of geometry. This kind of black hole has a name, Kerr black hole, named for the mathematician Roy Kerr, who first described it. And the shape matters. A spinning black hole is not perfectly spherical. It flattens slightly at the poles, like a planet spinning on its axis. This horizon bulges at the equator. And more than that, it gains a second boundary. Outside the event horizon is a region called the ergosphere. Here, space is being dragged around so fiercely that standing still becomes impossible. You could try to hover in place, but you'd find yourself carried along by the twist of space-time itself. Inside the ergosphere, you cannot rest. You cannot resist. You orbit inevitably even if your engines roar against it. And strangely, you can steal energy from it. If you are clever and careful, you could enter the ergosphere, split a particle in two, let one half fall into the black hole, and escape with the other half carrying more energy than it had before. This is the Penrose process, a theoretical way of mining the spin of a black hole. It sounds impossible, but it's rooted in real math. The black hole, even in its silence, offers something back. And deeper still, there is another twist. In a rotating black hole, the singularity is no longer a point. It stretches into a ring, a thin, spinning loop of infinite density. It changes everything. It changes the shape of time. It changes the structure of the fall. And it opens the door to impossible ideas. The equations just suggest, that a path might pass through this ring without destruction. That inside the spinning geometry, there could be a tunnel, a way through, a wormhole perhaps, or a bridge to another universe. We do not know. It may be illusion. It may be fantasy written in math because no one has seen the inside. No one has fallen through and returned. The singularity ring may still destroy all that enters. The tunnel may collapse before anything can pass. But the idea remains that the black hole, especially a spinning one, might not only end space but connect it. And isn't that a beautiful thought? That in the very place where the known laws fail, there may still be connection, still possibility. You're floating here now, imagining the spiral, not falling straight but curving, not crushed instantly, but swirled inward like a leaf caught in a storm of time. You pass through the ergosphere, feel the tug of rotation grow stronger, until even your thoughts begin to spiral. And ahead, that ring, that core, that loop of density where space and time collapse and rebirth might coexist. Would you pass through? Would you emerge elsewhere? Or is it simply the final circle, the loop that closes the fall? We do not know. But here, as you rest in this chapter of thought, you feel the turn of the black hole around you. The cosmos is not still. It never was. Even in the quietest dark, there is motion. And in that motion, there may be escape, or passage, or transformation, from one edge of the universe to another, from one version of reality to a new, unimaginable one. Some scientists dare to ask, could black holes lead somewhere else? Could the rotation carve a way through? Could these tunnels be real? The question stirs softly, not loudly, not with urgency, but like ripples on a sleeping lake. So let's follow them. Let's turn toward the next question, soft and bold all at once. Could a black hole be a doorway? Let's drift now into that speculation. A quiet thought for the night. Wormholes and wishes. There's a kind of question that feels different at night. It doesn't shout. It doesn't demand. It waits patiently at the edge of thought, like a star just beginning to rise. Tonight's question is one of those. Could a black hole be a doorway? Could it open somehow, somewhere, not into nothing, but into somewhere else? The idea has hovered in human imagination for decades. Sometimes in stories, sometimes in equations, sometimes in quiet conversations between curious minds. To consider it, we must return to the idea that space is not fixed. Remember the rubber sheet, the stretched surface that bends under the weight of stars and planets? Now imagine pressing two distant points of that sheet together, folding space so completely that one place brushes up against another. If the universe can curve, could it also tunnel? This is the dream of a wormhole, a tunnel through space-time, a kind of bridge, a shortcut, a fold in the fabric. The name is humble, a reference to small holes bored through apples by worms, turning long walks across the fruit into simple steps through it. In theory, a wormhole might connect two distant points in space, or even two different times. It could link the heart of one galaxy to another, or the past to the present, or perhaps two universes entirely. And black holes, especially rotating ones, might contain the geometry to allow this. It is only a possibility, one written in math, not in proof. Inside a rotating black hole, the shape of space bends so dramatically that a tunnel might form. It is called an Einstein-Rosen bridge, a thin connection between two separate regions of the universe. The entrance would be the black hole itself, a mouth in the dark. And the exit? Well, we call it a white hole, a theoretical opposite of a black hole, where nothing can enter and everything must emerge. White holes are not observed. They exist only in solutions to equations. But they remind us, mathematics can imagine more than our eyes can yet see. Still, there are problems. Real ones. Wormholes, if they exist, would likely be unstable. They could collapse in a flash, crushed by the same gravity that formed them. Anything trying to pass through might be destroyed. To keep them open, you would need something exotic. Something the universe doesn't seem to make in large amounts. Negative energy. Or exotic matter. Material with properties unlike anything in our everyday world. This strange stuff might resist collapse. It might hold the throat of the wormhole open, letting a signal or even a traveler pass through. But we have not found this matter. Not yet. Still, the idea lingers. It lives in science papers and chalkboard diagrams and whispered dreams between physicists and poets. Because wormholes are not just speculation. They're a conversation with the universe. A question we keep asking. Is there another way through? And maybe the reason the idea stays with us is not just scientific curiosity, but something more human, hope. The hope that even in the deepest gravity, even in the places that look like endings, there might be another side. That falling doesn't always mean vanishing. That descent might lead to a new emergence. It's a soft hope. Not loud, not insistent, just there. You feel it now as you imagine what it would be like to travel through such a tunnel. You enter the black hole. You do not collapse. You pass the ring of singularity, and you emerge somewhere else. Not as fiction, but as curiosity made visible. And even if the wormhole cannot carry bodies, perhaps it can carry information. A signal, a photon, a story. Perhaps the universe is not a flat page, but a folded book. And sometimes the chapters touch. Even Einstein, who helped build the theory of relativity, was intrigued by this idea. He and Nathan Rosen published a paper in 1935 describing such a bridge in spacetime. They weren't thinking about travel. They were wondering about unity, about connecting particles, forces, ideas. That's the thing about wormholes. They aren't only passages. They're metaphors. They connect not just places, but possibilities. And maybe that's what makes them matter. Because here, as you lie still in the dark, letting your mind drift across curved space, you feel it too. That wish for connection. That longing to step from one place to another without crossing the distance in between. Wormholes are dreams in geometry, and dreaming is what the universe does best. But even without wormholes, black holes connect us, not as tunnels but as anchors. In the center of nearly every galaxy, there is a black hole. Not a passage, but a presence. And it is to those giants we now turn. Because not all black holes are born from stars. Some are vast beyond comprehension, larger than anything you can see. And they do not just fall, they shape. So let's rise now from the soft wishes of tunnels and escape, and look into the luminous gravity of supermassive mysteries. All this time, you've been thinking about black holes as things that happen after stars die. As collapsed suns, tiny compared to galaxies, formed in the quiet aftermath of light. But now, let your gaze widen. Let your thoughts stretch across spiral arms and starlit halos, outward to the very architecture of the cosmos. Because in the center of nearly every large galaxy, including the one you call home, there lies a different kind of black hole, a supermassive black hole. Not one, not 10, but millions, sometimes billions, of solar masses pressed into a region smaller than a star cluster. And these black holes were not born in the usual way. They didn't come from a single dying star. Their beginnings are older, stranger, wrapped in a mystery as deep as their gravity. You might imagine them as sleeping giants, ancient presences curled at the core of galaxies, spinning slowly, feeding, occasionally shaping the very worlds around them. Our own galaxy, the Milky Way, spins around such a heart. We call it Sagittarius A*, pronounced Sagittarius A star, and we'll visit it more closely soon. But for now, let's marvel at the scale. Some supermassive black holes are more massive than 40 billion suns, a weight that bends not just space, but the evolution of entire galaxies. They are rare but not random. Astronomers have found a clear connection. The bigger the galaxy, the bigger the black hole at its center. Even though the black hole makes up only a tiny fraction of the galaxy's total mass, it somehow influences its stars, its motion, its future. How? That's one of the many questions we still don't fully understand. Somehow, these dark hearts regulate star formation. Maybe through their outflows, jets of energy and matter thrown from their surroundings. Yes, black holes can shine, not from the inside, but from the chaos around them. As matter spirals in, it heats to unimaginable temperatures. It glows in X-rays and gamma rays. It creates quasars, blazing beacons visible across billions of light years. And yet, the black hole itself remains invisible, a silhouette at the center of the storm, a quiet that hums beneath the brightness. But how do these supermassive beings come to be? There are theories. Some say they started small, born from the collapse of the first massive stars, then grew over billions of years by feeding on gas, on stars, on smaller black holes. Others think they formed very early as direct collapse black holes, immense clouds of primordial gas that skipped the star phase entirely and fell straight into darkness. But the truth is, we don't know. Even with all our telescopes, all our models, all our sky maps and data, the origin of these giants remains elusive. And maybe that's part of their magic. They are ancient, some already fully grown when the universe was young. They defy the timescales we expect. They seem too big, too soon. Their existence suggests something we haven't understood yet. Some hidden story in the early universe. Some missing chapter. And still, they remain central. Not just physically, but gravitationally. Galaxies orbit them. Clouds of stars sweep around their influence. Their mass helps hold it all, not as a command, but as a quiet anchor. And it's not just gravity they shape. Galaxies with more massive central black holes seem to form fewer new stars. It's as if the black hole controls the galaxy's growth, like a gentle hand turning down the volume when the music gets too loud. They regulate, they restrain, they guide, and yet they remain unseen, unfelt from Earth. You do not feel the pull of the black hole at the galaxy's center. It's too far. Its gravity is strong, but distance softens even the fiercest forces. You live in its galaxy, but not in its shadow. And yet, it shapes the galaxy you live in. Its mass helped sculpt the arms of stars, the distribution of dust, the quiet cradle where your solar system could form. You are here because of a supermassive black hole you've never seen. It's a quiet comfort, isn't it? To know that some parts of your world were shaped by things so ancient, so silent, so impossibly far, that even the night sky above your pillow was touched by a presence you cannot feel. And so tonight you can rest in that, knowing that you are part of something vast and connected. But you don't have to imagine from afar. Because your own galaxy, the Milky Way, has its own giant, its own sleeping heart, its own spiral embrace around a silent center. So let's go there next. Not in rocket or telescope, but in thought. Let's draw near to Sagittarius A*, your galaxy's quiet giant. You live in a galaxy called the Milky Way, a slow, spiral bloom of stars drifting through dark space. Graceful, immense, ancient. It stretches more than 100,000 light-years across. Within it are hundreds of billions of stars, suns with their own systems, worlds circling quietly, comets moving like thoughts in the far, cold night. And in the center, the very heart of this wheel of light, lies something quiet, something hidden, a black hole, a supermassive black hole. Its name is Sagittarius A star. It lives 26,000 light-years from Earth, wrapped in dust, concealed by clouds of gas and stars. You can't see it with your eyes. Not even the most powerful visible light telescope can. But it's there. We've watched the stars dance around it. Bright points of light tracing elegant orbits, swooping close, swinging wide year after year. Their motion is our proof. They move as if pulled by something enormous, yet invisible. And only one explanation fits: a black hole. 4 million times the mass of our sun, confined to a space no larger than a few of our solar systems. It does not shine, but it shapes. Like a magnet buried deep under paper, it arranges the dust above into spirals. Like a still heart beating inside stone, it influences everything without ever revealing its face. Sagittarius A asterisk isn't feeding much right now. It's a quiet black hole, not blazing like a quasar, not roaring with matter falling in. It sleeps, but its slumber is powerful. The stars nearby know it. They bow, they curve, they repeat their long, elliptical dances like prayers around a silent altar. In 2022, for the first time, we saw its shadow. Using a planet-sized telescope array, a collaboration of observatories across Earth, astronomers captured an image, not of the black hole itself, but of its silhouette. A dark center surrounded by glowing light, swirling in curved paths of gravity and speed. It was blurry, yes, but clear enough to confirm what had long been suspected. There it was, the invisible made visible, a reminder that even silence leaves a shadow. And what is it doing there, at the heart of our galaxy? Why do galaxies have black holes in their centers at all? We don't fully know. Somehow, they seem to form together, galaxy and black hole, growing in tandem, balanced like seed and tree. The black hole might shape the galaxy, or the galaxy might feed the black hole. Or both. A relationship of mutual influence, too slow and vast to witness in full. But you are part of it. Your solar system orbits the center of the galaxy, completing one galactic year every 230 million Earth years. The Sun is now on its 21st such trip. It was much younger when the dinosaurs roamed, and it will be far older when it completes its next circle. All the while, Sagittarius A asterisk sits in the middle, not guiding, not commanding, just being. And somehow that is enough. Its gravity keeps the inner galaxy from flying apart. Its history is tied to the Milky Way's own formation. The silence holds meaning, and though you do not feel it directly, it's part of your cosmic lineage. You're a child of this galaxy, and this galaxy has a heart. When you look up at the stars, you are seeing only a small part of it. The dust between you and the galactic center blocks your view. But with radio waves, with infrared telescopes, with the language of patient science, we have peeked through the veil. We have mapped the arms. We have followed the orbits. We have traced the faint glow that whispers of something vast and unseen. And we found it. Not a monster, not a destroyer, but a presence. Quiet, steady, waiting. Sagittarius A asterisk is not a threat to us. We are too far away. The Sun is safe in its distant orbit, and Earth is tucked in even farther. But it's humbling to know, to feel, that such a being exists at the center of your home galaxy. A heart made not of fire, but of curve. Not of sound, but of silence. And it isn't alone. There are other black holes, larger ones, brighter ones. But this one is ours. It has watched the Milky Way turn for billions of years. It was already old when Earth was born, already present when the first stars in our sky began to shine. And someday, long after our species is gone, it will still be there, still turning, still waiting, still watching the galaxy swirl. There's comfort in that. In a universe full of change and chaos, Sagittarius A** is a still point. Not eternal, but enduring. And while it may seem distant, cold, unreachable, it is also a reminder that we are part of something ancient, and that even in silence, there is connection. Now let your thoughts rest here a moment. Float gently at the edge of the galactic center. Feel the pull, not harsh but constant, not noisy but known. And from this place, look outward again. Because not all black holes are quiet. Some are not sleeping giants. They are searing, brilliant, and fed by galaxies. They burn brighter than all the stars around them. What are these glowing beacons, lit from the edge of darkness? Let's step now into the glare and meet the fiery faces of black holes in the chapter called Quasars, Bright from the Darkness. Black holes are often imagined as devourers, silent, invisible, starless. And that is true most of the time. But sometimes, when the conditions are just right, when matter flows thick and fast into the black hole's embrace, they shine. Not dimly, not quietly, but with a brilliance that outshines entire galaxies. These are quasars, the most radiant objects in the known universe. And yet, at their centers lie black holes. Let's pause with that thought, that something defined by absence can become the source of overwhelming presence. That something invisible can light the skies of distant epochs. Quasars are powered by supermassive black holes at the hearts of young, active galaxies. These black holes are not sleeping. They are feeding violently, continuously. Streams of gas, torn from nearby stars or drawn from interstellar clouds, spiral inward, not straight down, but in disks. Hot, dense, radiant disks of matter circling the black hole's event horizon. This structure is called an accretion disk, and it is one of the most powerful engines in the cosmos. As gas falls inward, friction heats it to extreme temperatures. It glows first red, then white, then blue, emitting light across the spectrum, from radio waves to X-rays. The black hole itself remains invisible, but the matter around it, just before it crosses the edge, burns with unbelievable intensity. This is how a quasar is born, not from the black hole's light, but from the chaos it creates around itself. You might picture it as a spotlight surrounding a hole in the stage. Some quasars shine with the energy of 1 trillion suns, all concentrated into a region smaller than our solar system. When we look at the farthest edges of the universe, we see quasars. And in seeing them, we look far into the past, because their light has taken billions of years to reach us. They are messengers from a time when the universe was young, when galaxies were forming, when black holes were growing rapidly, feeding hungrily on the matter around them. Quasars tell us about that time, about formation, about collision, about growth. They flicker, they vary in brightness, they send pulses of energy through space. Some even shoot out jets, narrow beams of particles moving at nearly the speed of light, stretching thousands of light years into space. These jets emerge not from the black hole itself, but from the edges of the accretion disk, where magnetic fields twist and launch particles into cosmic flight. It's extraordinary. That gravity, which pulls everything inward, can also create structures that shoot matter outward. Paradox of motion, a balance of fall and flare. And here's something quieter to consider. Though quasars blaze with unimaginable brightness, their light is not forever. They are phases, moments. Eventually, the black hole consumes all it can. The gas runs out, the chaos settles, and the light fades. What remains is still a black hole, but no longer a quasar. Just a quiet presence, waiting once more. Our own galaxy may have had such a phase long ago. Sagittarius A asterisk might have flared, its feeding visible across the universe. Now it sleeps, and maybe one day it will wake again. Quasars, then, are not separate from black holes. They are simply black holes in motion, black holes with company. Their brightness is not contradiction, but expression. Proof that even the deepest gravity can dance with the light. You are lying here now, imagining that glow, the swirling disk, the jets of fire and light streaming into the void. You are watching a black hole announce itself to the cosmos. And yet, no matter how brightly it burns, the center remains hidden. The event horizon never glows. The singularity never speaks. Everything we see is a whisper from the edge. That's what makes quasars so beautiful. They remind us that even in shadow, there is energy. There is transformation. That black holes, so often imagined as ends, can shine. And when two of them meet, when they spiral toward one another, something else begins to glow. Not in light, but in the very structure of space itself. The universe begins to tremble, to ripple, to sing. Let's drift toward that next wonder now. Past brightness, past silence. Toward the waves that black holes leave behind. Let's listen softly, and with awe, to the gravitational echoes. Imagine the universe is a vast, invisible lake. Still quiet, a black canvas stretched across all that exists. Now drop something heavy into it. Not a stone, not even a star, but a black hole. Not one, but two. They swirl, they spiral, they collide. And when they do, the fabric of space itself ripples. Not metaphorically, not poetically, literally. This is the strange and beautiful reality of gravitational waves. Ripples in space-time, moving outward at the speed of light, changing everything they pass through. But so gently, so faintly, that we only learned how to listen in the last decade. But first, let's return to those black holes. Imagine two of them locked in orbit. They have danced together for millions of years, pulled by each other's gravity, tightening their spiral with every turn. As they draw closer, they begin to move faster. Each orbit sends out a whisper, a tiny tremble in space, a gravitational wave. Each whisper costs them energy, and so the dance accelerates, faster, faster, until at last they merge. And when they do, the universe doesn't light up. There is no explosion, no flash of color. Instead, there is a pulse, a deep, slow wave that stretches and compresses space itself, as if the fabric of existence had momentarily breathed. That wave travels outward, undiminished by vacuum, carrying with it the memory of the merger. It moves not just through space, but as space. It does not pass around you. It passes through you, through your skin, your cells, the atoms in your bones, stretching and squeezing everything by the width of a proton. Too small to feel, but not too small to measure. In 2015, for the first time in history, we heard one. Using two massive detectors, each with arms 4 kilometers long, scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, captured the echo of two black holes merging over 1 billion light-years away. It was the tiniest of changes, a shift in length smaller than an atomic nucleus. And yet it was real, measured, heard. A new way of sensing the universe had opened. Since then, we've heard more. Dozens of mergers, black holes colliding, neutron stars spiraling in. Each one ringing the universe like a distant bell. Gravitational waves are not like light. They're not blocked by dust or slowed by gas. They pass through everything unchanged. They carry information from places light cannot go. The hearts of black holes, the edges of time itself. They give us a new language, not of sight, but of touch. And in this language, black holes tell their stories. Their size, their spin, their mass. From the echoes, we reconstruct the moment two massive bodies become one. A new black hole is born, slightly smaller than the sum of its parts because some mass has become energy. Wave motion, memory. The universe remembers in movement. These waves pass through the Earth all the time. Every second, ripples from far-off cosmic dances flow across the sky. You don't feel them, but they're there, passing through the mattress beneath you, through the floor, the planet, the air. They are the softest music. A background song the cosmos hums as it shifts and grows and breathes. And just like that, black holes are no longer just still, cold objects. They are singers, dancers, movers of space-time. And you are part of their audience. Not through telescope, not through light, but through the pure rhythm of existence. Gravitational waves are proof that the universe is not a static thing. It flexes, it sways, it feels, and it lets us listen when we learn how. Isn't it strange? To be lying still in bed, and to know that the ground beneath you once moved in response to black holes that collided before Earth had even formed? That somewhere deep in your cells you have already been touched by ancient collisions? We tend to think of black holes as things far away, distant, unreachable, unknowable. But gravitational waves erase that distance. They connect us. They carry us stories of violence and beauty, told in whispers that take billions of years to arrive. And still they arrive. Softly, faithfully. They speak to us that the universe is not silent. It speaks in curves. It sings in waves. And maybe, just maybe, if black holes can ring like bells, if space can ripple, if even silence leaves an echo, then nothing is ever truly lost. The mergers pass, the echoes fade, but something remains. A new black hole, a new shape in the cosmos, a new clue. And with every echo we hear, we understand a little more. Not just about where black holes come from, but about what they leave behind. What lies at their core, what remains at their hearts. What could possibly exist in that place of perfect collapse? And that brings us to another question, perhaps the most curious one of all. Could there be something at the core of a black hole? Something beyond the singularity? Some structure, some memory, some hidden physics? Let's drift there next, to the softest part of the question. Could there be a core? You've journeyed far, through the curve of gravity, the stillness of the singularity, the spirals of spin, and the tremble of gravitational waves. Now you arrive at a quiet question, soft as breath, yet as heavy as the cosmos. Could there be a core? A real, physical something inside the black hole, at its deepest center? We've spoken of singularities, those points of infinite density where our equations falter and time itself seems to end. But infinity is a signal, a warning, a sign that we may not yet understand what's really happening in the deep. Physicists whisper this not with certainty, but with wonder. They ask, what if the center of a black hole is not truly a point? What if there's more? Not light, not matter as we know it, but structure, geometry, a different form of space and time. A core, not solid, not glowing, but perhaps organized. Something that replaces the infinite, tames it, contains the gravity without collapsing meaning. Some theories offer answers. Quantum gravity, the great unfinished theory that seeks to unite the cosmic and the tiny, suggests that singularities may not be singular at all. That inside the black hole, something strange happens. Something that saves the story from ending. One idea speaks of a Planck core, a tiny region of space where gravity and quantum rules balance. A place of extreme density, but not infinite. In this view, the black hole's collapse halts before reaching true singularity. The core becomes the final shape. Small, unknowable, but not a paradox. Another theory suggests a bounce. That matter collapsing into a black hole may rebound, creating a new region of spacetime. A bud from which a baby universe might bloom. In that picture, the black hole's center is not a grave, but a seed. Not the end, but a new beginning. Elsewhere, there are even thoughts of fuzzballs. a string theory concept in which black holes don't have singularities at all. Instead, they are made of tangled strings, tiny vibrations woven into a compact quantum whole. In this version, the black hole is not a void, but a knot, a densely packed, humming tangle of energy and possibility. We cannot see these cores, not yet, and maybe never, because the event horizon still holds all its secrets within. Even gravitational waves can only speak of the surface, not the true heart. But science keeps listening. Every new signal, every merger, every ripple is a clue. We compare the waveforms, the soft chirps of colliding black holes, against our models. We look for irregularities. We look for a shadow of what lies within. We ask, do the final moments of a black hole's birth reveal what lies inside? We are like stargazers, watching for the flicker of a distant lantern in a house whose walls we can never enter. But we hope, and hope in science is not just dreaming. It's direction, it's attention, it's the decision to keep asking even when the answer hides. Could there be a core? Could the black hole be more than collapse? Could it remember what it once was? This question touches not just physics, but philosophy. Because to ask what remains is to ask what matters. And maybe you felt this too, in your own life, in your quietest moments. When everything falls away, what remains at your center? A memory, pattern, a pull? Something dense and invisible, yet unmistakably you? The black hole, in all its science, may be asking the same. It swallows light, curves time. It leaves behind only gravity and quiet. But perhaps deep inside it holds on to something. Not in defiance, but in essence. And maybe that's what a core is. Not a thing, but a promise. That not all is erased. That some truths endure even in the deepest dark. You lie here now, floating with that thought. The black hole no longer feels monstrous. It feels like a mystery with layers. And we are still peeling them back, one theory at a time. Perhaps we will never see the core. Perhaps it doesn't exist in any way we can imagine. But still, we ask. We imagine. We reach. Because the search itself is a kind of light. And yet, as we search for a core, we begin to see that black holes follow rules. They are not chaotic beasts, but structured presences. They obey laws of motion, of energy, of heat. Yes, heat. Because even black holes, so dark, so cold to the eye, have temperature. They follow the rules of thermodynamics. Let's drift toward those laws next, and rest within the strange idea that even the quietest black hole still has a kind of heat, a kind of order, a kind of truth. Let's explore black hole thermodynamics. And a deeper question still, if black holes evaporate, if they fade, do they die? Do they vanish? Or do they leave something behind? You lie here now, resting in the glow of quiet certainty, that even the most mysterious objects in the universe still follow laws, that nothing escapes the symmetry of thermodynamics, not even black holes. And that thought, that even the dark has rules, might help you sleep tonight, because the more we learn, the more we understand. Even the void is not chaos. It is continuity. So now, let's follow the last trail of heat, the last wisp of Hawking radiation, into the long future. Let's imagine what becomes of a black hole when its glow fades, when its mass shrinks, when its pull becomes soft and faint and finally gone. Let's drift gently now into the next chapter. Do black holes die? You might think of a black hole as cold, black, silent, a place where heat cannot escape, where light is swallowed, where nothing remains but the pull. But science, in its quiet unfolding, tells us otherwise. Even a black hole, so seemingly final, so perfect in its silence, has temperature. It has entropy. It follows the same rules that govern melting ice, boiling water, and the warmth in your skin. These are the laws of thermodynamics, the deep, ancient rules of energy and change. And black holes, in all their mystery, obey them. It began in the 1970s. A few brilliant physicists, Stephen Hawking, Jacob Bekenstein, and others, asked a simple question: what happens when you throw something into a black hole? You lose it, yes, but you also lose its energy, its mass. And energy, the universe insists, must go somewhere. It must be accounted for, cannot vanish without trace. So when something falls into a black hole, the black hole gets more massive. It grows. Its surface area, not its volume, expands. Specifically, the surface of the event horizon becomes larger. And this surface behaves curiously like something else in physics: entropy. Entropy is a measure of disorder, of information, of the number of ways a system can be arranged. A cup of hot tea has more entropy than cold water. A shuffled deck of cards has more entropy than one perfectly ordered. It is often called the arrow of time. Entropy only increases. And it turns out, black holes have entropy too. Not metaphorically, literally. Their entropy is enormous. A single black hole may have more entropy than a million suns combined. It's as if every bit of information that falls in, every atom, every particle, is not lost, but recorded somehow on the surface. The event horizon becomes a kind of book cover, holding everything that has ever entered, pressed into the shape of space. And where there is entropy, there must be temperature. Not temperature as you feel it with your hand, but a deep, quiet temperature, measured in radiation, in the trembling of empty space. This brings us to Hawking radiation again, the gentle glow emitted at the edge of a black hole, the slow leak of energy into the void. It's proof that even the darkest object is not beyond thermodynamics, that even black holes evaporate bit by bit, following the rules. So let's step through the 4 laws that link black holes to heat, to change, to the deep structure of reality. The zeroth law, the surface gravity of a black hole, the pull at the horizon, is constant, just like the temperature of a body in thermal equilibrium. This law says that a black hole has a uniform heat, a balance, a stillness across its skin. The first law, energy is conserved. The change in a black hole's mass is related to the change in its area, its spin, its electric charge. This law connects thermodynamics to black hole mechanics. It tells us that even collapse has rules. Even falling has equations. The second law, the area of a black hole's event horizon never decreases. Just as entropy always increases, so too does the black hole grow when it takes something in. This law brings us comfort. It suggests that information may not be destroyed, only folded deeper. The third law, it is impossible to reduce a black hole's surface gravity to 0. Just as you cannot reach absolute 0 temperature, there is always some boundary, some limit, an edge the universe refuses to cross. Isn't it remarkable that something as mysterious as a black hole still listens to the same laws that govern steam and starlight and skin? Even in the absence of light, there is order. Even in the deepest dark, there is structure. Entropy, energy, temperature, these are not just properties. They are stories about what is allowed, about what must remain. Black hole thermodynamics doesn't just connect us to science, it connects us to paradox. Because if black holes have entropy, then they must encode information. And if they evaporate over time, where does that information go? It brings us full circle to the information paradox again, to the mystery of memory and loss. Everything that begins ends. Stars are born in clouds of dust and gas. They shine for eons, burn through their fuel, then collapse or explode, becoming white dwarfs, neutron stars, black holes. You know this story, but black holes, they feel different. So final, so still, so complete. Once formed, they seem eternal, unchanging, unwavering, perfect in their silence. But they, too, are part of time. Black holes, for all their mystery, are not forever. They die, not in fire, not in bursts of light, but in something quieter. A long, slow, cold undoing. You've met this idea already: Hawking radiation, that gentle glow emitted from the edge of the event horizon, born not from the black hole itself, but from the restless vacuum around it. Every moment, a black hole loses a little mass, a little energy. A tiny portion of itself is radiated away, carried off as soft, invisible heat. The process is almost impossibly slow. A black hole the size of the sun would take about 10 to the power of 67 years to fully evaporate. That's a 1 followed by 67 zeros, a number that stretches far beyond the age of the universe as it is now. Supermassive black holes, the giants at the hearts of galaxies, would take even longer. So long, the universe around them might be cold and dark before they are halfway gone. But in time, in the patient language of thermodynamics, they fade. Their event horizons shrink, bit by bit, until the black hole becomes small, then tiny, then barely more than a whisper in space. And then it disappears, not with a bang, but with a final puff of heat. A last breath of existence, carried outward into the endless silence. What's left behind? We're not sure. Some theories suggest nothing remains. The black hole vanishes, its information having slowly leaked away in encoded patterns within the radiation. Others suggest a remnant, a small, dense object that holds the final trace of everything the black hole once contained. A frozen echo, a seed of memory. We don't yet know. The end of a black hole lies so far into the future that it may outlive stars, planets, galaxies, even time as we currently understand it. In the far future, after the last stars have died, after galaxies have drifted apart and the night has grown colder than physics can measure, black holes will remain. They will sit in the silent dark, radiating slowly, like coals in the ashes of the universe. They are the final act in the story of light and mass. And when they are gone, the universe may enter a new age, one without stars, without black holes, without motion. A deep stillness. This is called the heat death of the universe. A time when all energy has been used, all differences in temperature have evened out, all systems have run their course. And black holes, once the most powerful, the most dominant, will have contributed. They are not eternal. Even gravity lets go. And that's comforting in a strange way, because it means that change touches everything. That nothing is beyond time, not even the darkest heart of the cosmos. The death of a black hole is not violence. It's release, a long, soft unwinding, a surrender. And in that final surrender, the universe may learn something, may remember something, because even in death, black holes give back. Their radiation carries energy, carries information, carries the imprint of everything they once held. In their fading, they illuminate the deep structure of physics, the tension between general relativity and quantum mechanics, between the large and the small, between the known and the guessed. And you, floating in this quiet thought, might feel that same tension within yourself. You are a pattern of energy and mass. You burn, you shine, you move through time. And one day you too will change. Not disappear, but transform. Because like black holes, you are part of a system that does not waste. That reuses, rearranges, rewrites. Nothing is lost. Not truly. The atoms that were stars become your breath. The carbon of your body was forged in fire. The iron in your blood once lived in the heart of a supernova. And even if black holes fade, their essence echoes onward, in the shape of galaxies, in the flow of time, in the language of mathematics and light. So tonight, as you lie still, wrapped in gravity, bathed in memory, you can rest knowing this, that even the most powerful things must yield to time, that even darkness ends, and that what comes after, whatever it is, may be softer, quieter, but no less full of meaning. We followed black holes from birth to death, from the collapse of stars to the final tremble of Hawking heat. And now, at the edge of all we know, we pause. What comes next is not a certainty, but a question a boundary not of matter, but of knowledge. The edge where theory reaches and dreams begin. Let's float there together. Let's drift to the frontier of the known and the unknown, to the horizon of speculation, to the edge of theory. There comes a moment in every great journey when the path grows dim. Not because it ends, but because it opens. That moment is now. You followed black holes through birth and death, through time and curve, through silence and glow. You felt their pull, their mystery, their quiet rules. And now you reach the edge, not the edge of a black hole, but the edge of theory. Here, equations start to tremble. Predictions grow soft, like starlight scattered in fog. Science, so sure in the realm of test and measure, finds itself whispering. Because black holes, for all we've learned, still contain questions deeper than their gravity. Questions that stretch our ideas, that test the bridges we've built between concepts. You see, two great theories guide our understanding of the universe. General relativity, Einstein's elegant description of gravity, where mass curves spacetime, and spacetime tells matter how to move. Quantum mechanics, the strange statistical world of the very small, where particles flicker, where certainty dissolves into probability. Each theory works beautifully on its own. Each is tested, trusted, precise. But inside a black hole, at the singularity, at the smallest, most curved scales, they collide. Relativity says gravity wins. Space bends, time stops. Quantum theory says nothing is exact, nothing is lost. All is uncertain. And so the theories break. They disagree. And in that disagreement, a new truth waits. Physicists call this space quantum gravity, the hoped-for unification, a deeper framework that brings the large and the small together. We don't have it yet, not fully, only glimpses. We try through string theory, where particles are tiny, vibrating threads, and the fabric of the universe may have many more dimensions than the ones we see. We try through loop quantum gravity, which suggests space itself is made of tiny loops, a woven mesh too small to touch but strong enough to hold the universe. We try through black hole complementarity and holographic principles and bold new visions, where spacetime might emerge from information itself. These are not fantasies. They are mathematical dreams built on logic but not yet on proof. They offer answers, but they also reveal how little we still understand. What is time? Are space and matter the ingredients of the universe or consequences? Are black holes boundaries or beginnings? Could the singularity be smoothed out by quantum laws? Could the event horizon hold a film of memory? A screen where the history of everything that fell inside is written in code we haven't yet learned to read? Might black holes be holograms, three-dimensional shadows of deeper truths? These are the edges, the places where science becomes poetry and poetry becomes precision. It is not confusion, it is potential. And standing here, you, dear thinker, stargazer, are a part of it. Because wondering what if is a form of science, too. Every great discovery began as a quiet question. Every theory is a murmur in the dark. The edge of theory is not a wall. It is a field wide open, waiting to be walked. There's beauty here in the unknowing. A black hole doesn't just test our instruments. It tests our imagination. It asks if we're willing to look into the unknown and still believe that truth can be found. And slowly we are answering, with data from gravitational waves, with pictures of event horizon shadows, with collaborations across nations and decades. Each clue, each number, each whisper from the deep adds one more thread to a tapestry not yet finished. And maybe someday we'll have a theory that unites all of this. Maybe black holes will guide us to it because they are the perfect laboratories. Extreme, pure, honest. They do not lie. They simply are. And when our theories fail around them, it's not their fault. It's our invitation to go deeper, to learn more, to dream farther, to build better tools of understanding. And so, this edge, this moment of uncertainty, is not where the story ends. It's where the real story begins, where the known world hands you a lantern and says, go, imagine, build. Because even as we peer into the dark, even as the equations grow wild, there's one more thing we must remember. We are made of this, of stars, of atoms, of gravity, of time. We are not just watchers of black holes. We are their children, born from the same fires, spun from the same particles, part of the same unfolding. So now, before we return to the stars, before we step away from the edge, let's pause once more. Let's turn inward, because if black holes challenge what we know, they also remind us of who we are. Let's drift into the next chapter, one that brings this cosmic journey back to the body, back to breath, back to being. Let's remember, you are stardust too. After drifting through curved space-time, after circling singularities and tracing waves through the fabric of the cosmos, you return now not downward but inward, back to your own body, back to the quiet world behind your closed eyes, back to the simple, gentle fall of your breath. And here's the gentle truth waiting for you. You are not separate from the stars. You are not looking at the universe from the outside. You are the universe looking at itself. Black holes may feel distant, galaxies impossibly far, but everything in your body was forged in the very same fire. You are made of atoms, and those atoms were made in stars long ago. Before Earth had oceans, before the moon circled the sky, there were massive stars, bright, fast, burning. They lived, and when those stars died, they exploded supernovae. In those final moments, elements were born. Carbon, oxygen, iron, calcium, the raw ingredients for lungs, for blood, for thought. Those particles drifted, cooled, joined clouds of gas, became new stars, new planets, new possibilities. One of those planets was Earth, and on it, eventually, you. The calcium in your teeth was once inside a star's core. The iron in your blood came from a cosmic blast. The oxygen you breathe was shaped in stellar fusion. You are, in every physical sense, stardust. But it goes deeper still. You're not just made of the same stuff, you follow the same rules. The same gravity that holds galaxies in motion holds you gently to your bed. The same time that curves near a black hole moves quietly through your cells. You carry entropy. You radiate heat. You contain memory. Your thoughts are shaped by the same quantum fields that govern light and matter. Your life is not outside the cosmos. It is a thread woven into it. Every heartbeat, every breath, every blink ripples softly outward into the whole. This is not poetry alone. It is physics. Your atoms are in motion. Your cells exchange energy. Your brain runs on electrochemical pulses that obey the laws of electromagnetism. You are a smaller system in a much larger one, and yet not smaller in meaning, because even the larger structures, galaxies, clusters, black holes, cannot ask what you ask. They do not wonder. They do not look up. But you do, and that makes all the difference. You are the cosmos becoming aware. When you close your eyes and feel the warmth of your own skin, you are touching something ancient, a lineage that runs back through planets, through stars, through clouds of gas, through the Big Bang. Nothing in you is separate from this. And so, when you listen to black hole stories, you aren't just learning about distant objects. You are remembering, somewhere inside you, in the quiet spaces between thoughts, that memory lingers. And knowing that your life is shaped not just by biology, but by gravity, by chance, by starlight, it humbles. But it also comforts, because it means you belong, not by effort, not by merit, but by being. You are as natural as the tides, as true as the orbit of moons. And when you wonder about what lies beyond, what was past the event horizon, what remains after the glow fades, you're continuing the universe's story. You're helping it know itself. Even now, lying still, you're part of that. You're not waiting to join the cosmos. You're already in it. The same laws that govern galaxies govern your dreams. And so, let your thoughts drift gently back through all you've heard. The pull of gravity, the swirl of stars, the collision of black holes, the fading of light, the questions left open. Let it all settle in you, not as answers, but as wonder. Because there is still more. More to know, more to ask, more to become. The universe is not finished. And neither are you. Tomorrow, new thoughts will rise. New stars will be born. New questions will unfold. But for now, let yourself rest in the knowing that you're already part of something vast and still growing. The universe is not out there. It is here, in every cell, in every breath, in every quiet, curious moment. You are stardust, and the story continues. So as your breath slows, as your body softens, let's look outward one last time. Not to observe, but to rejoin. To feel what it means to belong completely. Let's go to the final vision, to the last perspective, to the place where black holes meet the universe itself. Let's drift into the cosmic horizon. Look far, farther than the stars you see, beyond the dust of the Milky Way, past the glow of the neighboring galaxies, past even the quasars burning in the deep past. Eventually, you will reach a limit, not a wall, not an end, but a horizon, a soft, glowing edge where the visible universe fades. It is called the cosmic horizon, the farthest distance from which light has had time to reach us since the beginning, roughly 46 billion light-years away. In every direction, it marks the limit of your current knowing. Anything beyond it is hidden by time itself, not because it doesn't exist, but because its light hasn't had enough time to arrive. And so, the cosmic horizon is not physical. It is temporal. It is a map made of age and light, a boundary drawn by the universe's own expansion. You lie here now, wrapped in blankets, surrounded by quiet, and that horizon stretches softly around you, like the sky around the earth, contains all you've ever seen, all science has ever measured, all starlight that has ever brushed against a telescope's lens. And still, there is more. Beyond the horizon, galaxies still spin, stars still shine, black holes still pull, but their stories have not yet reached you, and perhaps never will, because space itself is expanding. Not into something, just expanding. The galaxies farthest away are receding faster than light. Not because they move through space quickly, but because space itself is stretching between us and them. This is the nature of cosmic growth. It is not explosion, but unfolding. And it means that some places will always remain beyond reach, forever hidden. There is a deep stillness in that, the idea that the universe is larger than light, that beyond what you can see lies something you cannot touch, but which is still real. In this way, the cosmic horizon is a mirror of the black hole's event horizon. Both are boundaries. Both are limits of knowledge. Both mark a place where light cannot help you anymore. In a black hole, the horizon wraps inward. You fall in, and light cannot come back out. In the cosmos, the horizon wraps outward. You stay still, and light from beyond cannot come in. Both teach you this, that knowing has a shape, that information is not infinite, that every observer has a bubble of understanding, defined not just by sight but by time. And yet, within that bubble, a lifetime of beauty unfolds. Everything you've learned, from hydrogen's first breath to black holes evaporating in darkness, has arrived through the thin, patient path of light. Every star you've wished upon is already in the past. Every galaxy is an echo. Even the moon's glow took time to travel to your eyes. You live inside a story that arrives delayed, filtered through distance and expansion. And that story is still being written. The cosmic horizon changes every moment. It grows. New light reaches you. New data. New starlight from galaxies that were once hidden. The universe is not static. It breathes in time. And with each breath, your horizon shifts. But there's a deeper question, too. One that comes not from what's seen, but what's felt. When you know that there are places forever hidden, what do you do? Do you stop wondering? Or do you grow quieter in your awe? Maybe that's what black holes and the cosmic horizon both try to teach. That there is beauty in not knowing everything. That mystery is not failure, but invitation. That the edge is not a place to turn back, but a place to pause, to breathe, to rest in the truth that you are part of something much bigger than your eyes can hold. And still you belong, because the universe does not require understanding for connection. You're here, and that is enough. Let the cosmic horizon cradle you tonight. Let its silence soften your thoughts. Let the idea of unseen galaxies fill you with quiet reverence. Because though you may not see beyond, you are still connected. Your gravity touches theirs. Your atoms were born in the same fire. Your mind can reach beyond the limits of light and dwell in the calm idea that the story continues. Somewhere beyond that soft edge, more black holes spin. More stars are born. More time unfolds. And you, from your small corner of sky and thought, are part of that fabric. The universe is not a place you visit. It is what you are. And the horizon is not a barrier. It's a whisper that something waits, always softly, out there. And now, as your eyes grow heavy and your thoughts become clouds, let us move gently toward a closing thought. Not an answer, not a solution, but a final rhythm in the poem of black holes. Let's drift into the next and final chapter. Singularities and soft endings. This is where it all leads. Through gravity, through light, through time bending and waves trembling. You've arrived at the heart of the most mysterious place in the known cosmos. A singularity. It sits in the center of a black hole, or so we believe. A point where all our equations fall silent. A place where density becomes infinite, where space-time curves so steeply it folds into itself, where all direction loses meaning and all known physics stops working. You might expect drama, explosions, chaos, but that's not what a singularity is, not in the quiet telling of bedtime science. It is not fire. It is not fury. It is stillness, a perfect pause in the language of the universe, a place where motion, energy, even space have been pressed into silence. It's not that it's loud. It's that it's unknown. A singularity doesn't destroy understanding. It marks the edge of it. And that's a different kind of ending. One with gentleness. One with softness. Because here, at this final step of collapse, we are not sure what remains. Our maps blur. Our definitions dissolve. General relativity, which has guided us so far, reaches a point where it can no longer predict. Quantum mechanics, which dances so well with the tiniest of things, becomes tangled in contradiction. Together, these theories fall silent at the singularity's edge. And so, we do not know what a singularity truly is. Only that it represents a kind of cosmic humility. The universe saying, "Here, I still have secrets." It is not an error. It is a frontier, like the cosmic horizon, like the edge of theory. It reminds us that not all questions are ready for answers, that some truths arrive slowly, like starlight from a galaxy far away. And just as black holes are not all endings, so too, perhaps, singularities are not all destruction. Some theories say the singularity may not exist at all, at least not as we imagine. That instead of a true point, there's a structure small, dense, governed by rules we've not yet found. Others imagine it as a passage, a bridge, a doorway to another region of space and time. Still others say it may bounce, unfold, expand. But for now, the singularity remains hidden. It is surrounded by the event horizon, by lightless gravity, by distances we cannot cross. And yet, we know it's there. We feel its influence. We trace its presence in the way stars move, in the way time stretches, in the way black holes evolve. So we don't need to see it to know it matters. And maybe that's a message we can carry into sleep. That some things are real even when they can't be known. That uncertainty is not weakness, it's honesty. It's truth still in the making. Singularities are not just in the sky. They live in moments where something ends and something else begins. They exist in quiet transitions, in final breaths, in first steps, in dreams too large for waking thought. They are thresholds, not endings, not really. So as this journey draws close, as the last page turns in this story of stars and silence, let the idea of the singularity be not frightening, but freeing. A reminder that there is more to come, that not everything must be solved to be beautiful, that questions can be lullabies if we listen gently enough. And you, softly wrapped in this moment, you carry the cosmos within you. The singularity in a black hole may be hidden from light, but the singularity in you is not. It is your stillness, your wonder, your quiet knowing. It is the part of you that keeps asking, keeps imagining, keeps dreaming past the limits. That part is starlight, too. It came from a time before memory, and it will echo long after. So sleep now, not in forgetting but in becoming. Become the orbit, the wave, the core. You are not just made of matter. You are made of curiosity, and curiosity has no event horizon. It bends, it grows, it drifts outward forever, just like the universe. So let this chapter close not with an ending, but with a hush, with the soft curve of a question still unfolding in the dark. And in the quiet space between stars, let that question rock you gently to sleep, because the universe continues, and so do you, always.